For the Introduction to Epidemiology course, welcome to the lecture for the module Causality, Observation versus Experiment. So in this module, the outline for the lecture is going to include talking about the role of observational studies in clinical research, working through an example about studies of smoking and lung cancer, and then further discussion about whether observational studies can prove causality. So the objectives for this module are that students will recognize the role of observational studies in clinical research, that students will be aware of limitations of using observational evidence to assess cause and effect, and that students will be motivated to learn principles of good design for observational studies. So let's start with the idea of what do I mean by observational studies, just to make sure we're all on the same page. So research methods for human health studies can be broadly described as descriptive studies and analytic studies. Descriptive studies might be case reports, case series, or descriptive studies based on rates of disease in large populations. But those would generally be things that would describe trends and phenomena within a group, not necessarily comparisons or trying to address cause and effect. So on the right side of the slide, analytic studies fall into two types. There can be randomized studies. Most of you are probably familiar with the randomized controlled trial, which is an experiment with human beings as the subjects. And you can randomize individuals or groups. So then on the far right, non-randomized studies can include a variety of designs. Non-randomized interventions are one, but not one that we'll address very much in this class. So then farther down on the right, we get to observational studies, which are the main purview of epidemiology and of this course. And so the epidemiologic study designs include cohort, case control, cross-sectional, and ecologic designs. So I would say that under observational is mostly what epidemiology and this course are going to address. So first of all, thinking about clinical research, observational studies really are, even if they don't call themselves epidemiologic studies, studies using these observational designs, cohort and case control, and other observational studies are very prevalent in the clinical literature. So there are actually some articles that help me document this, that a high proportion of papers in obstetrics and gynecology journals, in urology journals, are observational. Interestingly, when people looked at the highest profile journals, the proportion of observational goes down. And so that's something that we have to acknowledge right away, that the high profile and really definitive cause and effect questions are subjected to randomized trials, and that is considered the best level of evidence. So evidence from randomized trials is preferred over observational studies. For a number of reasons that we'll talk about as we go through the semester, randomized studies can avoid confounding and certain biases that observational studies are susceptible to. So for instance, the grade guidelines, which are about assigning the grade of evidence for research supporting any particular question, the type of evidence would be highest from a randomized trial, lower from an observational study with a good design, and then other types of evidence even lower. Another group that is very interested in using research evidence to draw conclusions about cause and effect questions are the U.S. Preventive Services Task Force about the efficacy of preventive clinical measures to actually prevent disease or morbidity. So they have established a hierarchy of research designs, which again at the top puts properly powered and conducted randomized controlled trials. And then second, are well-designed controlled trials without randomization, and only below those do we get to well-designed cohort or case control analytic studies. So the idea here is these groups are feeling like observational studies have some value when you're trying to look at evidence, not as good as randomized trials. So observational studies may be poorly conducted or poorly reported, and there's also some literature encouraging us to do better in that regard. So the motivation for today's topic. Observational studies are subject to biases that would not be present in a well-conducted randomized controlled trial. And so the evidence is considered not as strong. So in my experience, sometimes people with a lab science background, they've been conducting experiments, they understand the scientific method. We talk about an epidemiology study and they say, oh, well, if the results of that study agree with their existing ideas, well, this supports their hypothesis or theory. But if the results of an epidemiology study, an observational study of humans in the community, disagrees with their existing ideas, people might tend to say, oh, well, that's probably the result of bias. So I don't find this a useful thought process. We're not going to learn anything from epidemiology if we say, if it agrees with what we believe, we still believe it. If it disagrees with what we believe, we still believe what we believe. All right, so I'm going to make that point a lot better through an example today, I think. So the course is going to provide you with some skills for an alternative approach. Instead of saying if it supports what you already believe, you still believe it. How about evaluating the observational study in terms of its design and quality? How susceptible is that particular study to biases? And then based on that evaluation, decide whether the results are good evidence of cause and effect or whether they might be explained by bias. And then I'm going to encourage you to be open to new knowledge from an observational study that may disagree with your existing ideas. So in the next video, we'll go on to an example.